So we're on objective 3, which is find the domain of a function defined by an equation. Yesterday we briefly recall the synonyms for domain and range, right? So the synonyms for domain and range, I call it Dixie and Roy. Dixie and Roy are two old hound dogs, and they just kind of help you remember what are other ways of saying domain and range, depending on the situation. Okay, so please be comfortable with the synonyms for domain and the synonyms for range. Okay. Now we're going to start off with finding the domain of a function defined by an equation. Okay, so we have here. First, we're going to start with the domain as the set of all real numbers. We want to first assume the easiest thing possible, that the domain is from negative infinity to positive infinity. We want to assume that every number is possible, right? Now, if we look and we test a number and it doesn't work, then we're going to check these next options. If the equation has a denominator, okay, exclude any numbers that give a 0 in the denominator. Okay, your denominator cannot equal 0. Remember, it is okay for 0 to be in the numerator, but it's a no-go for 0 to be in the denominator. Okay, so it's okay in the numerator, but a no-go in the denominator. If the equation has a radical of an even index, so meaning square root, fourth root, sixth root, eighth root, you want to find, you cannot have anything that would make the expression equal to a negative, right? And the reason being is because a negative times a negative makes a positive. So is there any way that I will ever be able to take the square root of something and produce a negative? No, not a real number. Those are imaginaries. Remember that? Okay, so main thing, remember, a negative times a negative makes a positive, and there's nothing we can do to change that. All right, are we ready to dive into some examples?
Never.
Ready or not, here we go. So, looking here, we want to find the domain of each of the following functions, starting with this guy. F of x equals x plus 4 divided by x squared minus 2x minus 3. Okay, the first thing to check is I want to be, oh yes, the domain's all real numbers, but is it all real numbers? No, because there's a what? There's a denominator. It's a fraction, guys. It's a fraction. Being negative has nothing to do with it. It is a fraction. There is a denominator, and the denominator cannot equal 0. So the denominator cannot equal 0. So that means that there's some value that will make this function not work at certain points. And we have to figure out what that value is, okay? So the denominator cannot equal 0. And so in order to solve this, we have x squared minus 2x minus 3. And I like to write not equal to 0, just because I'm reminding myself that these are the values that would make it equal to 0. And I'm trying to find what's going to make it not equal to 0. But that's just a way of writing it for me. You don't have to write it like that. You can write it as an actual equation. How do you solve a quadratic? You have the x, you have the box, and you also have mental math. Okay, so with mental math, because my leading coefficient is a 1, all I'm doing is asking myself what multiplies to give me -3, but adds to give me -2. So what two numbers? What did you say? A -3 and a +1. And that's what I'm solving for. So what can x not be? So x can't be what? X cannot be -1 and x can't be 3. And those are my domain restrictions. So these are my restrictions. I don't have enough room for my restriction. Okay, so those are my domain restrictions. These are things that my domain cannot be. And there's two ways of writing this. We have interval and we have set notation. Do y'all remember that? Okay, so with set notation, remember our braces? We say that x is all real numbers, and such that x cannot equal -1 and x cannot equal +3. That's our math sentence that's saying it. That's our set notation. Exist. It's if E and C had a baby, it makes the exist symbol. It's a C with a line. Okay, that's what it is. E and C had a baby. Okay, the next one is our interval notation. So interval notation, that's when we had our U's and our parentheses and brackets. Y'all remember doing that a little bit? So we read just graphs from left to right. So we start at negative infinity. We're traveling to -1. You're like, oh no, I gotta stop. Then we restart from -1 to 3. And you're like, oh no, I gotta stop. And then we continue 3 to infinity. These are both ways of writing the domain. It's hot. It's hot.
I'll go with you if I maybe say it loud.
It's hot. We're just gonna be hot, guys. There's too many bodies for my. Once I get over 10 people in here, I have to open the door.
Too much bodies in here now.
Okay. All right. Here we go. We're gonna find the domain of another one. All right, we have x squared minus 9. What is this function? You don't have to do anything. What's the function? It's x squared minus 9. What family is this function part of? What family of functions is x squared minus 9 part of? Not on your paper, is it just prior knowledge? It is a quadratic. Thank you, Alexis. Alexis, can you please tell your class why this is a quadratic? If you put in a calculator, it makes a parabola, right? Also, the highest power of this function is what? 2. If my highest power is a 2, that makes me a quadratic. Okay, quadratic is our longest unit in Algebra 2. We literally spend 10 to 11 weeks on it. So I was anticipating a whole class. Libby, be quiet. All right. Now, what is the domain of any quadratic? All real numbers. So the domain here would be from negative infinity to positive infinity. That means I can choose any number and it's going to work in this situation. I'm not going to get any undefined point. If I plugged in 1,000, it would work. If I plugged in 0.0003, it would work. I can plug in any number from negative infinity to positive infinity, and it will make a true statement. Does that make sense? Okay, not true statement. It will not be undefined. All right, our last example, we have h of x equals the square root of 3 minus 2x. Okay, is this all real numbers? Why is it not all real numbers?
All of it. It's being. What's it called? It's not a quadratic.
Not a quadratic. What is it? Anyone want to help him out? What is this? A square root. Okay, this is a square root. And because it's a square root, you cannot have negatives underneath the square, right? Negatives not allowed. Okay, so when we're looking at this, you're going to take whatever's underneath the square root and you're going to have 3 minus 2x, but it has to be greater than or equal to 0. Okay, it has to be greater than or equal to 0. And how do I solve this? What do I need to do to get x by itself? I'm going to subtract the 3, right, Isaac? After I subtract the 3, what am I going to do? Yeah, what am I doing? Well, I already did that. What am I doing?
Yes. Or negative. Divide by -2.
Divide by -2. Now get rid of it. I have to divide by -2 because that's multiplication. Pay attention. Okay, so we have x. It has to be greater than or equal to 3/2. Yes, I didn't flip my, thank you. Flip the switch. And why did I flip? Because if you divide or multiply by a negative, you have to switch your signs. Thank you. I was too focused on someone not paying attention to me. Okay, so that's my domain restriction. So when I would write this means the two ways of writing this, per set, you're saying that your x is all real numbers, but x has to be less than or equal to 3/2. I draw the ugliest braces. I can't fix it.
You have to write the set.
No, I'm just showing you so that if you see it, you know where it's coming from. Your interval is saying that you are less than, so it's from -infinity to 3/2, and it's a bracket because it can be equal to 3/2. So notice because it says equal to, I have a bracket, not a parenthesis. All right, so those are the three main finding from a domain of function right now. Things that the main three things. So either you're getting all real numbers or you have some type of restriction because there's a denominator or a even root. Got it? All right. All right, I think, yeah, we're on to a real world example. Here I have a rectangular garden, has a perimeter of 100 feet. Express the area of the garden as a function of the width, okay? So first thing first is we have a rectangular garden and its perimeter is 100. What is perimeter? The amount around, right? So that's the perimeter is the outside part of this. And so we know that the perimeter equals 100. Okay. And so here we have our we know the width, but do we know that, well, we don't know the width and we don't know our length. But it says to express it as a function of the width. So here we have our length. That's L. So perimeter equals what? It would be 2 L's plus 2W. Agree? Why is it that? Because you have two of everything, right? I don't need to write L plus W plus W. Okay. Now the area. How do you find the area of a rectangle? It's our length times our width, right? Okay. So it wants it as a function of the width. That means I need to get rid of the L. I can use perimeter and solve for L and substitute, right? So our job is to get L by itself so that I can replace it in my area formula. What do I need to get about 10? So I have 100 equals 2L plus 2W. What are the two steps I need to do to get L by itself? Subtract the 2W. And then divide by 2. So that's going to give me 50 minus W equals L. So now I can substitute in and be in terms of W. So area formula. So area equals, and we have 50 minus W times W. Simplify it. That gives us area equals 50W minus W squared. So for a rectangle with a perimeter of 100, as long as I know the width, I can find the area. Does that make sense? That's what it says in terms as a function of something. That means if I know that piece of information, I can do what I have to do with the problem, okay? Now, real world. When we have this, we know that its domain is from negative infinity to positive infinity. But can you have negative width? No. So our domain is not negative infinity to infinity. Our domain is, it would have to be something greater than 0, right? Because you would have to stay positive. Otherwise, it would not work. Does that make sense? Okay. So therefore, it has to be, what would make 50 minus W 0? 50. So our W would have to be 50 or greater. Does that make sense? So let's look at it from a what's that thing called? A calculator. Put as bar. Probably should press the on button. So we have
Put the on button on that thing.
I know it's weird that it makes you do that, but it does. It treats it like it's the real deal, McCoy. All right, so that's our equation. So when I go to graph, I can't see anything. I'm gonna need to zoom a little bit. So notice I go to zoom and I'm gonna do what's called zoom fit and see if the calculator will make it a little easier in my life. It kind of did. All right, so at this point, I know that what matters is where does it become a negative? And so I'm looking at 0. Well, I can also just go look at my graph. So we have 0, and then notice here at 1, it's 49. At 2 is 96. At 3 is 141. So looking at these values, my width can't be what? It has to be greater than 0. But if I go any higher, remember, I only can add up to 100, right? So if I'm looking and saying, okay, what can add up to 100? If my width is 2, that puts it at 96. But if my width is 3, I'm at 141. So all these other factors have to come into play as far as, oh, I have a limit on being 100. So my width is limited from 0 to 2. There's a limit on what my width can be. Do we see that? And that limit would be from 0 to 2, because anything higher, what happens? It gets too big. Okay, so just real world trying to tie together. Oh, these are areas, Shauna. You're tripping. Those are areas. I should have graphed that one first. This is 0 to 50. Area can be whatever it wants. Yeah, I'm sorry, my bad. We're looking at area and not the thing. I'll fix that in our video. All right, operations. Let me stop. Wrong stop button.